Hi, everyone. Welcome to Azure Cosmos DB Live TV. It's Build 2021 week. Build again. I've got a bunch of my teammates here with me today. I think we had maybe a record number of announcements. I'm counting. Let's see. We got 1, 2, 3, 4, 5, 6, 7, 8 different big announcements from the team this week. So I brought my team along so they could talk about it, because I'm betting you might have missed a thing or two with all the excitement going on this week. So I've got with us Thomas and Deborah, Tim, Saranya, and Stephanie. Say hi, everybody.
Hey.
Hey there.
Hey, everyone.
Did you guys enjoy Build this week?
Oh, definitely. It was a very intense week for us and for our users as well, I guess.
Yeah, sure. Thomas, my gosh, you had 3 major announcements. You had, in fact, all 3 were GA announcements, if I'm not mistaken, right?
Two of them.
Oh, 2 of them. Okay, so
yeah.
One was just a preview?
That's right.
So, yeah, well, anybody have any favorite moments from Build this week they want to talk about? Anything they saw or heard that was, outside? I mean, of course, we've got our own exciting things, but other exciting things they saw this week that they wanted to share? No,
well,
nothing?
I felt that a couple of things. One, the format of Build was different than usual. Shorter sessions, more crisp. But outside of all of that, one interesting trivia that caught my eye was Satya's keynote had a coronavirus model behind him. If you had caught that on the screen, like they had a COVID ball with a virus thing right behind that, very subtly suggesting, but it was very good.
I loved it. His keynote was great. I liked Hanselman's keynote as well. That was kind of a unique and fun format. In fact, every time I watch him at Build, I have a bunch of stuff that I've got to go try out now. It seems like every year that happens, like I need to go block out a couple of days so I could go download or install or try or tinker with all the cool stuff he showed. So yeah, lots of fun.
I love Deborah's demo. Her demo was awesome here.
Yeah, absolutely. I know our star, our keynote star, Deborah.
Honestly,
you rock it every year.
Thank you. Awesome. It was just great to be able to demo. I think we packed like 4 or 5 different features there in a very short time frame, and many of the features that this crew actually worked on. So it was really great to represent Cosmos DB and show off all the new features.
You must be exhausted, I'm betting, all the practice and rehearsals and stuff. Are you going to take some time off after this week?
I've got like a week booked off in June, so that'll be nice. It's always good to relax after Build.
Yeah, absolutely. just sleep, I think, is a good thing, right? So yeah, all right. Well, hey, let's go through some of the announcements we had. First up, Thomas, why don't we talk about all your great stuff this year?
Absolutely, and I think it's a good thing to kick off that impressive list of announcements with, one of the things we announced a couple of days ago, which is now the general availability of our serverless offering, right? And for our viewers who are not necessarily familiar with serverless on Cosmos DB, but I guess it's now high time to become familiar with serverless on Cosmos DB. What it is, essentially, it is our consumption-based model, right? So it is a model that is radically different from the other model that is available on Cosmos DB, which is provision throughput. In provision throughput mode, as the name kind of implies, you have to provision some capacity, right? So whenever you create a new Cosmos DB resource, you have to kind of project how much throughput that resource will be required to deliver. With serverless, it's a completely different approach in that there is no capacity planning, right? You create your resources, you don't provision any kind of throughput, and at the end of the month, the only thing that you get charged for is the request units that have been actually consumed by your database operations, on top of the storage, of course. That's pretty much the same as with provision throughput. So no need to provision any kind of throughput. Obviously, the result of that is that our entry price, the entry price for Cosmos DB, is lowered even further. If you are new to Cosmos DB, or even if you are new to the serverless offering, you might ask yourself, then when is a good fit to use serverless, right? Because we have those two models. When should I go with serverless? There are plenty of situations where serverless is actually a good fit. And obviously, the most obvious one would be if you get started with Cosmos DB, you are a brand new Cosmos DB user, you start from scratch, and obviously you're not going to do a lot over the first days or weeks. You're probably going to discover our SDKs, get familiar with the Cosmos DB models, go through our quick starts, etc. And so you're not going to issue a lot of requests, right? At the beginning, probably a handful of them. And that's typically the kind of situation where serverless shines in terms of cost effectiveness, because, well, when you don't use the database, you don't get charged at all. But on top of that, I think it's important to understand that any kind of workload where your database is going to sit idle most of the time is probably a good fit for serverless. So this covers, obviously, any situation where you're getting started with a new project. So you start with some development, you do some testing here and there, proof of concepts, some prototyping. Again, most of the time, your Cosmos DB instance is going to sit idle, but sometimes you will have some bursts of activities. But even beyond that, we have already seen quite a lot of customers who have gone in production with our serverless model. Even though we were still in preview, some customers and some users were very keen to actually start leveraging that new model, and it works very well for, again, those kind of applications that are very bursty, right? And you have very long idle times between those bursts. Those are situations where serverless yields a great value. And before we switch to the next feature, I also wanted to mention that obviously there is a good pair of serverless on Cosmos DB that is Azure Functions, right?
Yep.
So if our Azure users want to build completely serverless applications, so applications and solutions that are really consumption-based end-to-end, pairing Azure Functions with serverless on Cosmos DB obviously works very well.
Yeah, you could put hook change feed up to that, and you could do serverless event-driven applications. I mean, that's pretty cool.
Yeah.
Actually, I heard a lot of people pairing up Azure Functions with our new serverless thing now. So I think that's so awesome, and just being able to start and only pay for what you use. I mean, what a great way to start. I mean, and then of course more great ways to start with Deb, but I don't want to steal her thunder. But yeah, that's great, Thomas. I know people are excited. A lot of chatter on Twitter about it as well. So fantastic job. Yeah, if folks, you want to learn more about serverless, I've got this link up here, aka.ms/cosmos-serverless, and you can learn more about our new serverless offering. So what's next, Thomas?
What's next? Well, there is another big feature that we have made generally available at the Build conference, and that is our role-based access control with Azure Active Directory. And this is actually something that Mark, you and me covered, I think it was like 4 to 5 weeks back here.
Yep.
So it's exactly that. It's exactly what we went through during our sessions a month back. The big update is that, well, that feature used to just be in preview, and now that feature is GA, which means that it is completely and fully supported for any kind of production workloads, right? So we know that we had customers who are kind of holding back because, especially for security features, they are cautious and they wait until Microsoft says, okay, green light, it's GA, you can move forward. This is the case now. And I've said that many times in the past, and I like to call that feature probably the biggest security update we ever had on Cosmos DB.
It's not understating it, I think.
I don't think so. Yeah. If you look at the actual impact of that feature in the way our users are going to approach security on Cosmos DB, I think it's a very substantial contribution to the overall security landscape on Cosmos DB. It's the next generation of access control on Cosmos DB, essentially, because what that feature lets you do is to use Azure AD identities instead of primary keys when you connect to Cosmos DB. So if you were thinking about getting completely rid of primary keys, and I do know we have many customers who are actually considering that, if your goal is to really use Azure AD as the end-to-end vehicle for authentication and authorization, this is not something that is available with our new RBAC. I won't go into too many details because, again, we covered that a month back. But I just wanted to remind our viewers that what comes with this new feature is a very fine-grained permission model, right? And that permission model goes very granular in what you can authorize, and it lets you implement scenarios that were just impossible to implement before. Typical scenario is if you want to make sure that your client application is only able to do, let's say, document lookups by ID and nothing else. No queries, no reading the change feed. You can only fetch the documents that you know the ID of. That was just impossible to do before, right? Because we haven't that level of granularity. And this is something that is now available with that new RBAC. And last note on that feature, obviously, once you start using Azure AD identities in order to authenticate your requests, those same identities get logged in your diagnostic logs, right? So when you look at your data plane requests in our diagnostic logs, you will see that we are also tracking the identities and the role assignment ID that was used to authenticate and authorize the request. So if you want to know, what were the identities used to query my data, to delete my data, again, something that wasn't really possible before, and this is another gap that we are bridging with this new feature.
Yeah, fantastic. Yeah, I'm so excited. Like I was saying when we were together a few weeks ago, this was something that when I first joined the team was something we were really wanted to do. But man, it took a lot of work. I mean, like 2+ years of work to get there. So yeah, fantastic stuff. Question for you here from one of our viewers. Can you configure RBAC in a way that a user can only read documents with a certain customer ID?
Oh, that's an interesting question. So when it comes to the scope of a role assignment, what we enable our users to do today is to assign a role at either the Cosmos DB account level, or the database level, or the container level. Okay, today we don't support any finer granularity in the actual scope assignment. This is on the roadmap, and actually the next step for us, without revealing too much, is to actually embrace the integration with other Azure services to make role management even more centralized in Cosmos DB, and with that will come finer grain assignment of the roles.
So we'll have like a row level security, kind of like what SQL's got. So.
Yeah, it's not exactly row level security. What we are looking at is attribute-based access control, right? Which is another layer on top of role-based access control. Is basically ABAC, attribute-based access control, is a way to specify conditions on top of your role assignments. And this is exactly what our viewer here is looking for, is to be able to assign a role with an additional condition that has to be met for that role to be honored. So not possible today, but definitely a requirement that we have identified and that we will bridge in the coming month. Probably over the next month, so over the month of June, we will start previewing the next step, the next click stop for us, which is that centralized role management. And with that will gradually come attribute-based access control.
Ah, very cool.
Yeah,
very cool. All right. You want to learn more about our RBAC support, feel free to check out that URL below. And you're not done. We've got one more thing. You should take some time off too, Thomas.
I will definitely. This was an intense build for all of us. Another feature, and I have to say another big one. In the security landscape, and this is the preview launch of Always Encrypted. Another big milestone, very important for us, because essentially what's happening here is that Cosmos DB is joining that Always Encrypted family, right? We are the first non-relational data store to join that family and to become Always Encrypted compatible. Okay, so definitely for all our very security conscious users, this is probably something that will catch their attention. And for those of them who have used Always Encrypted in the past on SQL, right? Because this is a technology that has been available on SQL DB and SQL Server for, I think, 5 to 6 years now, 5 years for sure. It's essentially the same concepts, right? This is, let me actually switch to the next step. This is essentially client-side encryption, right? So this is encryption happening client-side in your client application through our new SDK extensions. So this is a way for you to encrypt data either on-prem or outside of Cosmos DB within your application before it gets sent to Cosmos DB. And this is done, as I will show you in a moment, because I think we have some time to dive a bit deeper in that feature. This is done by letting you define what's called an encryption policy. Okay, so when you create new containers on Cosmos DB, now you have that option to define that encryption policy. As we will see in a moment, that policy lets you define how you expect the data to be encrypted client-side before it gets sent to Cosmos DB. On top of that, that encryption is controlled by what we call CMKs, customer managed keys. So those are encryption keys that you as a Cosmos DB user manage on your own by storing them in Azure Key Vault. Okay, and again, I will show all of that in just a moment. So typical use cases where you may want to look at our new always encrypted capability is specifically when you want to protect very sensitive data that has specific confidentiality characteristics, right? So when you have specific properties, I could call them columns, right? For if we used a relational vocabulary here, if you have specific columns in your data set that you want to protect behind specific encryption keys, this is the kind of scenario where you want to look at always encrypted. Typical example I usually give is an HR application, right? That obviously is going to manipulate very sensitive data about employees. You know, you have social security numbers, maybe salary information, information that you don't want anyone to have access to. Even someone who has actually access to your Cosmos DB account maybe shouldn't have access to those very sensitive bits of data. And so that's what clients and encryption lets you do, is to protect those specific properties behind those encryption keys. And only people who have access to the encryption keys have also access to those properties. So what that really is property access control. Mark, do we have some time to dive into a bit more details around that feature?
Yeah, sure.
Okay, great. Yeah, I just wanted to show you that thing in action. It can be very brief. I know that we'll probably have another session here dedicated to always encrypted, but just to give you a glimpse of what that feature looks like. And the first thing I wanted to show you, I will just briefly go to the actual public documentation of the feature that is now live, obviously, because the first concept that our Cosmos DB users need to understand in order to start using that new feature is that concept of encryption keys. Right? Obviously, we are going to encrypt data, and that encryption will happen with encryption keys. And the way it works is with two layer of keys, okay, two different layers. And the best way to read that little diagram is from right to left. Okay, I'm sorry. So the data that you are storing in Cosmos DB is going to be encrypted with DEKs, data encryption keys. And those are keys that you will have to create yourself, client side, through our new SDK extensions. And again, I'm going to show you that in just a moment. Those DEKs, those data encryption keys, are also stored in Cosmos DB. Okay, so we are storing consistently the data and the keys used to encrypt the data in the same Cosmos DB account. Now, to give you full control over the encryption, obviously that's not enough. So the second layer of keys is those CMKs, those customer managed keys. So those are keys that you manage and store in Azure Key Vault. And we use those keys to wrap, which is another fancy name for really encrypt, right? We encrypt those DEKs with your CMK before we store them in Cosmos DB. The result of that is that not only, when you're using always encrypted, not only Cosmos DB never sees the plain data that you want to encrypt, but on top of that, we even never see the plain data encryption keys. Okay, so Cosmos DB is completely put out of the loop here. Everything is happening client-side in your application, and only your application sees the plain data, the plain sensitive data, and also the data encryption keys, which gives you obviously a very sales level of security and protection over those sensitive properties that you want to encrypt.
That's very that's great. And we don't we can't see anything.
We can
just garbled data basically coming in and out, right?
Yeah. And this is a requirement that sometimes comes from customers operating in certain industries and verticals, right? They have that requirement that the public cloud provider should be out of the loop, and there should be no way for us to actually get our hands on any of that sensitive data, either data itself or even the encryption keys.
Wow.
Yeah. So to use always encrypted, it also starts in Key Vault, right? Because it's in Key Vault that originally you are going to create your CMKs. So here I have a test Key Vault instance. If I browse to the keys here, you can see that I have already created a couple of keys. Okay, so this is extremely simple to do. You can either generate new keys directly from Key Vault, or you can import existing keys. And so now that I have my CMKs, my customer managed keys stored in Key Vault, I can start writing code against those new SDK extensions. So I'm going to switch here to Visual Studio to show you just in good old C# what that looks like. And by the way, taking this opportunity to clarify that Always Encrypted is available today in both .NET and Java. So if you are one of our precious Java customers, you can start testing that feature as well. So the first thing to do is to slightly change the way you initialize your Cosmos DB client, right? So here I am initializing my client with a connection string that points to our beloved emulator. I'm using the local emulator here to do my tests. And as you can see here, I am attaching a key store provider, right? So I'm kind of augmenting my Cosmos client with a key store provider. That provider is basically my gateway to my Key Vault instance, right? So this is the object that the Cosmos DB SDK is going to use in order to have access to those CMKs, those customer managed keys that I have stored in Key Vault. And the way we authenticate that access is obviously through AAD, right? So if I switch back here to my Key Vault instance, if I go to the access policies, we can see that I have granted access to a couple of AAD applications, right? And here in my code, I am using the credentials of one of those applications to make sure that my client code here is allowed to actually access my Key Vault instance and access to my keys. Yeah. Once this is done, once my SDK has been initialized, I'm just going to do, usual initialization. I'm going to create a database and then fetch back the database once it is created. And then next step is to create the DE-keys, okay? The data encryption keys. And just to clarify, I'm switching back here to our documentation. This is already created in Key Vault. Now I'm going to create those DE-keys, right, that we are going to store in my Cosmos DB account. So we have introduced a couple of new methods that let me create those DE-keys. I just give them a name, so I pass an ID, and essentially I pass the metadata that is required for the SDK to wrap those DE-keys. And so basically, I am passing the key identifier of those CMKs I have created in Key Vault before. Okay, so I've created a couple of data encryption keys here, and once this is done, I can finally create a new container with that new option of attaching a client encryption policy to my container. So we have a Fluent API here to do that. And here I am creating an encryption policy that says that every time I write a document to Cosmos DB, specifically to that container that I am creating, property 1 should always be encrypted with key 1 in a deterministic fashion, and property 2 should always be encrypted with key 2, hence the name Always Encrypted, in a randomized fashion. Okay, so and so this is a policy that's going to sit together with my container, and anytime you spin a new instance of our SDK, it's going to fetch that policy to understand how data should be encrypted whenever you write data. Okay. Again, I won't get into too many details because we'll have a specific session.
We should totally do a bespoke podcast episode.
Oh, we should, and we will definitely. So yeah. Let me just briefly go to the last part of the code here. This is where I'm writing data, and as you can see here, this is just a normal create item async call, right? There is nothing specific here because my SDK has been initialized with Always Encrypted being enabled. So my SDK knows now that it should look at the properties I am writing in order to encrypt them accordingly. So here I'm just doing a quick test. I'm writing property 1 as a string. Property 2 is actually a JSON object, right? It's a complex type that itself contains an array of values. So just to show you how that encryption works. And after that, I'm just going to read back my document. I have set a breakpoint here, but let's just run that thing, giving it some time to warm up. It's going to do a bunch of things here, right? It's going to create a new database, a new container, a couple of encryption keys. And once I hit my breakpoint, which will happen soon enough.
Cold start.
Yeah. Here we go. I'm going to switch to my emulator here. Okay. The database has been created, the container as well. And then when we look at that document that I have just created, that's the result, right? I hope this is visible enough. Okay. As we can see, the shape of the document obviously has been preserved. Okay. But all those properties that I have specified as properties to encrypt, well, they've been encrypted. Property 1 was a string. Now it's completely opaque. Property 2 was a JSON object, and it is still a JSON object, what we have done is that we have encrypted all those leaf values, right? And that they have become completely obfuscated for anyone who is looking at the data without having access to the encryption keys, which is pretty cool. Next, I'm just doing a read item. So here again, nothing specific. The SDK knows that I'm going to read the data that is potentially encrypted, and it will decrypt it automatically and transparently. So I'm doing my read item here, outputting the result on the here. Oops, where it is? Let me just drag my here. So I have, again, I haven't done anything special. The data has been transparently decrypted through that read item call. Same happens when I run a query. Now what I can do, and again, this is something we'll get into details once we have a session dedicated to always encrypted. I can actually filter on encrypted properties. Okay, so here property 1 is encrypted. I can actually write a query that does an equality filter on property 1. I just have to use that new add parameter async in order to inject the actual value I want here. Just running that thing again. And as expected, here again, the document comes back completely decrypted. Okay.
Very, very cool.
Yes,
Absolutely
it is.
Amazing. Great stuff, Thomas.
Thanks, Max.
Awesome.
Yeah, we tried our best to make that thing as seamless as possible and as transparent as possible. I think the team has done an amazing job in bridging that gap between always encrypted that works in SQL with an equivalent that now exists in Cosmos DB. Before we switch to the next feature, I just wanted to also clarify that this is now in public preview, so it's available for everyone who wants to give it a try. As always, when running previews, we are extremely eager to get user feedback, right? Because this is the time for us to make sure that feature is well calibrated and there is nothing missing. And so if you browse back to our public documentation, you will see at the very top of the documentation that we are mentioning a email address that you can use in order to reach out to the engineering team that is behind the feature. And so by all means, don't be shy. Please give it a try and drop us a message telling us whether it's working well or it's not. We want to hear everything from you to make sure that once we push that feature to GA as well, which will happen probably in the second semester, it's all working well and serving your requirements in the best manner possible.
Very cool. Thank you very much, Thomas. And man, a lot of stuff.
Yes.
Definitely take some time off too, right? We should all do that, right? So I'm going to take tomorrow off. I'm going to go golf. So
Nice.
Yeah, I also got to get a driver's license for California. So life. So hey, next up we got Saranya, who's going to talk about another feature that's been in our user voice since 2015. I think it is maybe one of the oldest, and I believe it's number one. There it is, 5,309 votes. Yeah, amazing. I actually marked that thing as completed, but it's not, right? It's just started. Oh, no, it was Linux emulator. I marked as completed, and then I went back. I'm like, wait, we only have SQL API for that. So we're still in the process. So I moved that back to start, but this one here, still early on this, but Saranya, how are you?
Very good. Hey, thanks, Mark. I guess all of us from the Cosmos DB team, we are super excited because no better time than build to announce user voice number one developer productivity feature, partial document update, and that's what we're going to talk about. It is available as preview right now. Next couple of months, we should see this GA. At this point, and maybe we can just do a quick rundown of what we have and what we've heard. And so we are trying to make it as robust as possible and as easy as possible. Cosmos DB partial document update is inspired, say, by JSON patch REST specification, and it's essentially to push down partial document update for SQL API docs, right? We have a robust patch spec, and we'll talk a little bit about what that looks like. A lot of heavy lifting at the back end in terms of to support our multi-master scenarios. So that's very interesting as well from our end. And to all the audience's point of view, it was user voice number one. So we sooner then later we really had to get this out. One thing that is interesting and worth mentioning is really path level conflict resolution, and we'll see that at the demo as well. Essentially, what it means is if you have a JSON doc and you are updating two different paths across different data centers anywhere that we're sitting, we now isolate it at a path level. So very transparently, automatically, the two documents will get merged without any conflicts, right? So that to me was pretty fascinating. Main benefits of using partial document update. Definitely the network payload is going to be much lower because you're only going to send the changed values or the partial updates that need to, and not the whole document body. Together to that, there would be lower latency, end-to-end latency. And also the client-side user developer is saved, right? Doesn't need to do ETAGs and OCC checks. And subsequently, because of that, no extra read operation required. So there's a little bit of RU saving there. But to kind of be clear and highlight and look at all patch APIs out in the market, patches are pretty expensive operations, right? Because there's a lot of heavy lifting being done at the server end. We are not going to overcharge patch. Like, it's not going to be more expensive than replace operations at document level. In fact, it will be cheaper than that. But the use case per se for using patch is not to lower our use. Usage is more around developer ease of use, ease of development, lower network payload, lower end-to-end latency. As I said, there will be benefits in RU as a byproduct. Client-side CPU cycles that's a huge one when we have larger workloads. So that's useful. And in situations where customers have multi-region write deployments, it really shines, right? And this also is useful for Cassandra patch, which will take benefit of that. Today, the Cassandra native wire protocol supports patch, but moving on to the multi-region scenarios where two different regions are updating the same document, but at different paths, they will be transparently merged. However, if the same path level is being conflicted, then we will fall back to the native default conflict resolution, be it last writer wins or custom conflict resolution that's provided, unless it is CRDTs. So
I think it's worth repeating and just making clear, because I think there was a large misconception among customers that this feature would save them a ton of RU if they did a lot of high volume updates to, basically where they had kind of asymmetric update patterns on their documents, and they were frequently updating a small number of properties in a really large document, and they were incurring high RU costs.
Right.
This is not going to fix that for customers because the merge operation itself on the server side is still a pretty expensive operation to do, right? I mean, customers should, if they do have that heavily asymmetric access pattern, should shred the document. That's still the correct guidance, isn't it, for customers?
Right. So, and if you look at distributed databases in market today, all of them, the batch operations are actually more expensive. And that's the user feedback we received and the checks that we did as well. But our promise on Patch API is definitely not going to be more expensive than what we have today.
Sure.
We would see cost savings, as I said, in not doing the extra read for every patch. So that's one benefit. And two, it's going to be slightly lower than replace cost. So there's going to be a margin there as well. But absolutely, Mark, the intent is if you're really looking purely for RU savings, then probably not the best choice. However, there are other better benefits, like just client-side CPU is a huge benefit for large workloads. As I said, latency, network payload checks, just the fact that you don't need to do OCC checks at the clients. Those are legitimate reasons.
Yeah, I had a question from a viewer here. How much will it cost to partially update a document? So it's basically the same price, is what you're saying, right? There's no change. It won't get more expensive, but it won't it doesn't get cheaper, right, than what it would have been?
Yeah, so currently when we do a replace cost, we will be bounded by that at the upper limit. It is going to be the same RU billing model, right? And how does RU billing model work? It works basically by converting CPU IOPS memory of performing that operation. And for patch, the way we can, and as we say, in patch, we have options to patch using a single patch operation, and as we see here, and when we have a patch command, it's actually a list patch, so it's an array that we need to pass. You can pass by default up to 10 patch operations within a single patch command. If we go more than one patches, the overall benefits in terms of RU will be very significant. Because you're able to patch multiple operations without needing to do multiple replaces within one replace cost. So essentially, you can do one patch with up to 10 patch operations, but play only equal to one replace cost. The upper limit is replace cost, is what I'm saying. We are seeing about 75 to 85% of replace cost based on our optimizations, but we should see that when it goes to GA.
And to be clear, that's a patch on 10 patches on a single document.
That's right.
Right. We don't do
within one patch command. So when we pass
Right.
the patch command, you can submit a different multiple patches on the same patch command being a same REST request that is being issued to our package service.
Got it.
Right. So yeah, what do we support today? We support multiple operations. We support add, remove, replace, set, and more importantly, increment. So just to highlight, we inspired by JSON patch, but also we deviate a little bit by increasing more capabilities, like for example, increment by incrementing plus or minus X value. That's a very interesting feature as well. So if it's an numeric data type, you can pass plus or minus X without needing to read that value. So that's good.
Very cool. Yeah, you can create like little counters, basically.
Yeah.
Yeah.
Similar to that in terms of modes, we also support what is a conditional patch, and that for us was a very interesting piece. And so you can now have SQL-like filter predicates, and you can say you patch only if a particular value is greater, lesser, equal to, not equal to, or all of the similar to SQL predicate values, and you can patch based on that. So that conditional patch. We also support bulk and transactional patch modes as well.
Wow. I'm going to have to rewrite a bunch of my demos with all this cool.
We could do a separate live TV session.
We should totally do another one. But I hate waking you up at 4 a.m.
Today we support .NET Java mainly. JavaScript's also supported via stored procs, right? So with that, let's go and take a look at a demo and see how this works out. So what I'm trying to do here is let me open up a small utility tool that I have, a collection. This our Cosmos DB collection, and each item in this collection typically is a pixel, so it has an X and Y coordinate. ID is the logical partition key. That's what it is. And essentially, we do have R, G, and B. So there are 3 colors. So what we're going to do from here is we're going to read this collection and paint a picture because we have RGB values. Clearly, at the beginning of this demo, all of these values are 0, which means that we have a black canvas. So let's go and run a simple SAML-based .NET application just to show and read from the collection and display all the values, RGB values of the collection on a screen. Right? So the system's booting up, and slowly you should see as it's reading values, this whole screen becomes black, and that's what you see. So essentially we have a canvas. The demo is to show you what are we going to paint in this canvas using Patch API and how can it look like. Right? So for that, I'm going to go ahead and minimize this and share with you the setup a little bit. And the setup really is we have 3 client apps, right? Just to say that, and we are simulating a multi-region write scenario here. We have the endpoint and the authorization key. Let's actually kick off these patch operations while we are talking, so that it needs to patch every single pixel. So that's going to take a bit of time. So let's kick that off. And essentially, if you say I'm kicking off the first one, which is R, which is the red color. So it's patching red color here. Hopefully, if you start seeing that there are pictures of red. And while that's happening, I'm also patching green. And green, I'm patching from bottom. So you'll see this picture loading from bottom. And also, if you can really squeeze your eyes and see this, I'm trying to fit in a bunch of things on the screen, is red is patching from central India, green's patching from central India, and this is patching, say, from Hong Kong, right? So let's run all of these patches. So 2 of these patches are patching this document, the screen, from top to bottom. And you will see that one of the colors, the blue color, is patching from bottom to top. Essentially, what's happening is from different parts of the world, in different regions, the patch operation is issued to the Cosmos DB collection. As it's being issued to the Cosmos DB collection, for the same document, and that is critical, and we just saw the document has 3 different properties, R, G, and P, which means it has 3 different paths. And these paths are not conflicting to each other, which means they can be transparently and very automatically be conflict resolved. And that's exactly what is happening at the backend. The blue is being patched, green value is being patched, and the red value is being patched. Of course, it's run pretty fast. So you see the red is already over and the whole document, the red feed has come through. But then as we see green and blue, as they're conflicting, there are parts of blue from the bottom, but they're also automatically patching along with the green. So just to kind of show this variation, we thought we'd patch it from the top and the bottom. So we can see this colors being changing as you see on the screen. We just have to wait a little bit for this to get done.
What a cool demo.
And
where'd you get this demo from?
We built it.
You did. This is fascinating. What a great way to show off patch.
The intent of this demo is, as you might say, that why are we actually just bombarding Cosmos DB with so many write operations? And you probably don't want to do that. But I want to highlight this is a very cool demo scenario. In reality, you might not do this, but painting a picture to showcase the value of writing it from different regions and being able to do this in a multi-master, that is the power, or at least the message we wanted to pass through this demo.
Wow,
just wait for a couple of seconds here until this demo gets done, and we'll see the last parts of the picture. And let's close this right here. And let's go back to our picture that we painted. Let's go back to our Visual Studio that's running. Just wanted to kind of highlight that we were trying to have some sort of a secret Santa database, and literally we are trying to go ahead and paint Mona Lisa as a picture. Now, while this is happening, we can quickly go back and take a look at what this patch operation looks like. And that is available today. The SDKs are public, free on GitHub across .NET and Java. So you can actually download the SDK and try it right now. And we'll also tell you how to enroll from the server side for patch, and it's open for all users.
Yeah, sure. Let me throw, I got that. So people want to sign up for our private preview, you can go to aka.ms/cosmosdb patch. And then we've also got a URL here, aka.ms/cosmosdb_getting-started_partial-document. That's a long, short link.
Sure. Yeah, and we have it on the deck as well. So what we just saw in this demo, kind of just to highlight a couple of beats, right? I wanted to call out the path level conflict resolution that we just did. And at the back end, the work is non-trivial. The work to be able to efficiently store a patch and being able to reduce the size to a patch spec this JSON document, and to be able to create a set of resolved changes and being able to synchronize consistently based on the consistency pattern. All of these are happening at the backend. We do have an SDK, as you saw. Works across all consistencies, all APIs today, works across all modes, direct and gateway mode. So no other features that we are talking about today or existing Cosmos DB features are not compromised, right?
Yep.
So these are things that goes on.
Definitely non-trivial work here, implementing CRDTs, which is, I think, at the heart of what we did here in implementing this this capability.
Here, let's just revisit what we saw with Mona Lisa, right? What if we did not have path level conflict resolution, but we had decided to do a patch, but do it at an item level, which is the whole JSON document level. We ran this with an update operation, and we saw what we got. And this is just kind of a comparison of what the system would have looked like in a multi-region scenario when the same document is not being resolved at a path level, but more at a root item level. So definitely benefits of patch out there here. And now let's switch gears quickly to the JSON patch SDK and what it looks like. As I said, it's a REST API following the RFC of JSON patch. So we would then send multiple operations. So it's a list of ops. And for .NET, it essentially looks like, hey, I can go and create a list of patch operations. And these operations can be add, set, remove, increment, etc. And then I would go and execute patch item async to execute the patch. And similarly, the conditional transactional existing the SDK is exactly what it'll follow. Similarly, for JavaScript as well, very similar scheme.
Yeah, great.
Right.
Well,
So if you're excited to get started on patch, this is how we sign up and get started with. You can sign up for preview at this aka.ms link that Mark projected as well. Cosmos partial doc update. Less than, I would say, about 12 to 16 hours, we will enable your account. It's open for all users to go and sign up. Preview. The SDKs are public, as I said, so you could go ahead and download either the .NET or the Java SDK. And then there is docs that we can look up to. So if we want to go and take a look at the docs that's available to get started, that's the link which is there. I encourage you to go and take a look at specific scenarios that we said. How can we patch a single operation? How could we patch multiple patch operations within one patch command? How could we do conditional patch? How could we do transactional patch? So we have it all that, and maybe we can do another session to walk through that. Intent is we are resolving questions and issues, so request you to definitely use these issues to give us feedback, or you could write to us at CosmosDB patch preview at Microsoft.com. So looking forward for all of you to try and give us feedback, please.
wonderful. Well, thank you so much, Saranya. That was, excuse me, that was awesome seeing that. And I can't wait to have you back so we can dive in even more. And now you've inspired me with that cool demo of yours. I got to come up with a cool picture or something and do a bunch of patch operations on it. I don't know what I would do, but it'd be something.
We'll upload these demos and samples as we go along in the next couple of weeks. So folks will have samples to get started. Today we do have samples with which is there in the README, but scenario-based demos is also something we put it up. So.
Very cool. All right, thank you. Next, Stephanie's back, and if you missed it last time, she's going to talk a little bit about our Linux emulator that just came out. Lots and lots of happy folks on Twitter as well this week, and certainly lots of people. I know I probably inundated you with early preview requests because I basically just said, yeah, we got it. DM me and I'll get you hooked up. So I hope that was okay.
It's too late now, Mark.
No, I know, right? But
yes,
let it
definitely.
slip out of the bag before our announcement there. So
Yeah.
but then how do you can't keep it secret when it's sitting
No.
out in the public Docker registry, right? So
Exactly.
but anyway, so now it's all here. Yeah. So tell us about the Linux emulator.
Right. So we are super excited to announce, that we have support for Linux emulator. So Saranya just showed you partial updates #1. Now we are fulfilling #2, which is great. This request actually has 2,000, almost 3,000 upvotes, right?
Yeah.
So this is really great to see. So if you go into our documentation, I'll go into details on how to get started with the emulator. And basically, for those of you who are not familiar, the emulator basically is a local install of Cosmos DB for Linux or Mac OS users. Today, we already have an MSI Windows version of the emulator with instructions here, where you can develop locally with the emulator. And now we are having support for Linux and Mac OS, which is amazing. So with this emulator, it's currently in preview, and we have support for SQL API. And so let's jump right into a quick demo on how to get it up and running on your computer right now.
Yeah, sure.
So, okay, great. So first off, you will need to go ahead and visit Docker Hub and install the Docker desktop for Mac OS. So once you go here on the link, you will have two options: Mac with Intel chip and Mac with Apple chip. So one thing to note is that the emulator today only works for Macs with Intel chips. So once you go ahead, hit download on that. I've already downloaded for the purposes of the demo, and you've added it to your application folder. You can then go into Docker. You will see it up here, and you click on Dashboard. And you should see basically a couple of things on the Docker. You can start running some containers here with getting started. You can also see the images. So I have my Cosmos DB Linux emulator image already here. And you can try to use this for managing all your Docker containers as well. But once you have Docker installed, let's go back to the instructions. We have detailed step-by-step instructions on how to get this up and running. First step is to retrieve your IP address from your local machine. So if we go ahead and copy this, and let's go open up a terminal here. Let's go open up a terminal. Sorry, I recently got Invisalign, so you might hear a bit of a lisp. So once you go ahead, copy that command, hit enter. Now you've retrieved your IP address. Next step is to go ahead here and pull the Docker image. So this Azure Cosmos emulator in the Linux folder. So this is actually going to pull the image. I've already ran this command because it does take a little bit of time. So once you run that command, then you can go ahead and run the Docker image with a certain configuration. So let's copy that over and let's paste this. Okay, so if you take a look at the Docker command, we have a couple of properties here. So these ports numbers are what the emulator needs these ports to run on. We also have -m, which is memory. 3 GB is pretty good to start off. And then we also have cores. And then this is the name of the emulator. So in this instance, we're calling it Test Linux Emulator. We also have the partition count. So for this demo, let me go ahead and change that just so it can start up a little bit faster. But the default partition count is going to be 10. So I'll just go ahead and do 3 here. And then you also have the emulator enable data persistence. This basically is set to true. So this allows you to still have your emulator data between container restarts. And lastly, we have the IP address override, which we just set. Okay, so once we have that, we will go ahead and run this. And whilst this is starting up, let me go here into the documentation. And if we scroll down, you will see details on configuration options. So all of these configurations that we've just set -P for ports, your partition count, memory, CPU, data persistence, we have the description of what they mean and optimal settings that we recommend users to use. Okay. So while this is starting up, so now you can see the emulator has started. And let's go ahead and see if we can view this in localhost running today. So let's go to here. And basically, you can do HTTPS localhost port 8081 _ explorer index HTML. Okay, so we're getting this connection is not private. If we see details, it's because the website doesn't have a valid certificate. So with the emulator, you have to go ahead and manually trust the certificate of the emulator. So let's go ahead and do that now. So you can open up a new tab, a new terminal window. And what we're going to do is run the IP address command. Actually, let me go ahead and copy that from the documentation. Here we go. Right, we're going to go ahead and set get the IP address once more in this new terminal. And let's set that. And once that's done, we need to then download the certificate of the emulator, emulator.pem. Right. So, okay, now we have the emulator. So if we do ls, you will see we have an emulator certificate. So since we have the emulator certificate now, we have to go into keychain to import the emulator certificate. So let's go ahead and go to File, Import, and we're going to import the emulator certificate. Okay, I'm going to type in my password. Okay, great. Now we have the emulator certificate localhost already imported into Keychain. What you're going to do next is double click on the certificate, on the localhost certificate. Make sure it's the certificate called localhost. And you're going to go into trust. And then you will then have to enable always trust. Okay. So once that's done, you can close this out. Type in my password once again. Okay, so now the certificate is set to always trust. And let's go try and see if we can get the emulator running now. Perfect. So now you see, congratulations. Now you have the emulator running and you have your connection string information, localhost URI, and your primary keys. You can then take this and this information and include it in any sample app. So for those of you who have not used Cosmos DB before, this basically emulates the Cosmos DB portal. And so we also have sample apps that you can get started with, .NET, Java, Node, and Python, that you can just go ahead and download and run that. And if we go into the Explorer, you will be able to create a new container. We're going to do like a test or something. Let's do this. And let's go ahead and say name, for example. Okay. So once this goes in, we have our containers there. And then you're able to upload your data and play around with Cosmos DB, which is always great.
Very cool.
Yeah. I'll just quickly go over one last thing. So in our documentation, we have these step-by-step instructions on how to get it up and running. And like Thomas mentioned, this is in preview today. So we would definitely love for all of you to go ahead and test this out. Towards the end of the documentation, we have detailed steps on how to troubleshoot maybe if you're experiencing some crashes or some Data Explorer errors, performance issues. So we have some step-by-step instructions on troubleshooting, as well as how to refresh the Linux container. So one thing to note is that if we go back to our terminal and we do Control-C here, let's stop this. Okay, great. And if you try to run the Docker container again with the same command, it will actually give you an error because you already have this test Linux emulator running. So the way you have to start this back up is you have to do Docker start and then the name of your container. So we have all the details here on how to refresh your container if you need to, and start your container again, as well as how to report an issue. And you can send us an email if you have any feedback, any feature requests, or any issues running the emulator.
Awesome. Well, great. Well, thank you so much, Stephanie. That's very exciting. I mean, knocking off number 1 and number 2 at the same conference. I never thought I'd see that.
Yeah, impressive. Great job, team.
Yeah, definitely.
Cosmos DB is in a ship mode, yeah?
What's that?
I said we are in a ship mode now.
Yeah, we are. We listen to customers. We're trying our best. Great. Well, next up, I've got Tim, who's joining us again. He's been on the show a couple times already, so I think this is number 3 for you so far. So you and Thomas, actually, you're both frequent flyers on the podcast here, I think. So, which is good. You're shipping stuff, right? So that's the important thing. So, and Tim, you're going to talk to us about our new integrated cache.
Awesome. Thanks, Mark. So 2 days ago at Build, we announced the Cosmos DB integrated cache, and it's a really great way to save costs for read-heavy workloads on Cosmos DB. So the reasons you might want to use the integrated cache, I mean, they're really not all that different from the reason you'd want to use caching with any other database out there. It's to ensure manageable costs, right? Low read costs, and ensure low latency when you have a really large scale workload. Now, the integrated cache is different from other caching options that you might have in Azure because it's integrated into Cosmos DB. So it is built into Cosmos DB. It's designed from the ground up specifically for use with Cosmos DB. That also means you can only use it with Cosmos DB. So if you have another workload, let's say, that uses Azure SQL or uses some other database out there, well, we would love for you to use the integrated cache. Unfortunately, it only works with Cosmos DB workloads. What's pretty cool is because it's integrated into Cosmos DB, it actually can use the same SDK that the rest of your Cosmos DB account can use. So that means the way you'll write queries, the way you'll ingest data, the way you'll read data, it doesn't change whether the request goes to your backend database or goes to the cache. And on the next slide, I'll actually talk about how that works. Actually, it's a slide after this one. Basically, your integrated cache is within something called a dedicated gateway. So the amount of capacity that you want to have available for caching is basically going to be dictated by the size of the dedicated gateway that you go and provision. The dedicated gateway, I mean, as the name suggests, is a gateway that both routes your requests, so it's effectively a routing gateway, that has a significant amount of memory available for caching data. It's built hourly based on the provision size you pick. And that size is based on the D series of Azure VMs. So you can pick from D4s, D8s, D16s that each have, I mean, this amount of memory and CPU. Now, it's fully managed in Cosmos DB. So all you need to do to get started with this is pick a dedicated gateway, configure the size, and every dedicated gateway automatically has the integrated cache enabled. The way it'll work is, let's say you have your app and it connects to Cosmos DB with direct mode now. This would mean that your app went and talked directly to our backend partitions. Basically, you ran our SDK on your app, and it would the SDK would have logic, right, for routing queries across partitions, doing writes, reads, things like that. If you go and provision a dedicated gateway, basically what you'll do is you'll change out your connection string to a new one that's special for this dedicated gateway here. And when you do that, your request will first go to the dedicated gateway that will then go and route your request to the relevant backend partitions.
So there's no more direct mode when you use this, basically. It's basically like regular gateway, but it's not multi-tenant gateway like it used to be. You're basically got, as the name says, dedicated. So
Right.
yeah.
Right. And because it's dedicated to you, that's a really important word. It's because it's dedicated to you, you have so much memory available that you can use some of it for caching. So if you provision a dedicated gateway, you can use the memory on the dedicated gateway, not only for routing requests, but also for caching data. So Mark, like you mentioned, you want to make sure you use gateway mode when you use the dedicated gateway, because it requires your app to basically talk to the dedicated gateway node first. And then if your data is in the cache, then the dedicated gateway node will just send, the response back to the client without ever needing to touch any of your backend resources.
Got it. And you need to specify that because direct now is default, I think, in our SDKs, right? So yeah, okay.
Yeah, it's a great point. If you want to use the feature, there's 3 things that you need to do. Or I guess 4 things. The first thing that you need to do is just provision it, right? That one's obvious. The other 3, I guess, aren't so obvious. You want to make sure you're using gateway mode. You want to make sure that you're using the special dedicated gateway connection string that we give you when you provision the dedicated gateway. And then finally, you want to make sure that if you want requests to utilize the integrated cache, you want to make sure they have eventual consistency. I won't go into all the details today since this is just a quick overview, but recommend reading our docs to learn a lot more about this. Basically, the integrated cache is going to cache your point reads, so key value lookups of data, and queries. What we do with queries is we basically transform it into a key value lookup, where the key is the query text and the value is the query results. The good thing about the cache is you don't have to manually populate the cache and validate the cache, write logic to specifically to read the cache. It's all handled automatically for you. Right now, the eviction is going to be LRU with TTL. So if the cache fills up, we evict data that was basically least recently used. The TTL that you set is configurable on a per request basis. So if you have some queries that you want to, let's say, have a max staleness right of the data that's returned of, let's say, 10 minutes, and other queries where you have a requirement where this can be 2 hours, you can go ahead and configure this on a per request basis, basically, to manage the consistency of the data in the cache.
Yeah, very cool. Yeah, no.
So right here, I have an Azure VM that's in the West US 2 region, and it's connecting to a Cosmos DB account in the West US 2 region. And this Cosmos DB account that I just created in SQL API has a dedicated gateway provisioned with an integrated cache. So the first thing I'll do is just go ahead and ingest some data through our dedicated gateway endpoint. It's not very exciting, but I just want to show just an example of how when you do that, you get pretty comparable latency in RU charges to what you'd otherwise get if you just ingested data normally in Cosmos DB. Right here, I'm doing some latency tests with a super small document. If you've seen Mark do this demo, it might look really familiar. I actually adapted it from one he wrote to show off a lot of our global distribution features and multi-region replication features. But basically, all we're doing is just sample writes and reads and queries with 1 KB documents. The next thing I'm going to do is 100 test point reads without caching. If we do a point read, it's going to cost about 1 RU, right? If it's a small 1 KB document, it's going to cost you 1 RU to do this point read. And when the request goes to the back end, that's what we get. The latency is pretty good, right? The latency is 2.6 milliseconds. And the RU charge for this request is 1 RU. Now, in most cases, if the request costs 1 RU, that's dirt cheap, right? If with a 1 RU request, you could run this 1,000 times for 1,000 RUs for free, right? Because 1,000 RUs is now within free tier. So from a cost perspective, point reads are incredibly cheap. But if you wanted to reduce the per operation cost even further, the way to achieve that would be with caching. If I go and repeat these point reads, these key value lookups on the item ID, but now with the integrated cache, the latency is about the same. Right? It's still really good at 2 point something milliseconds, right? 2 milliseconds and change. But now the RU charge is 0. So you basically, I mean, you got these nearly for free, right? You didn't even touch any of your backend RUs, any of your backend resources. So if you had an application that repeated the same reads over and over and over again, you stand to save quite a bit with the integrated cache.
I got a question from a viewer here.
Yeah.
Can you manually invalidate the cache, like when a document's changed?
So the short answer for right now is no. You can't manually invalidate the cache. The way you want to manage the consistency of the data in the cache is going to be through setting the max integrated cache staleness setting for your request. Long term, though, this is definitely something we're exploring in between the public preview and GA. So actually, I'm going to steal Thomas's idea. And in our documentation, if you try out the feature, look at our docs. A few days from now, you'll start to see like an email address that you can reach out to with feedback. I'll throw that on there. So if you have any feedback as you're trying it out or any kind of wish list things that you'd want, please don't be shy. The way I think of the feature is we've kind of built the bare bones, right? We have basically an LRU cache with TTL, and we don't have a lot of other ways for, let's say, invalidating the cache. But if you have things that you want, these are certainly things that we can add on in between the public preview and GA.
You could try what Saranya and her team did, which is create a GitHub repo for issues.
No, that's a nice idea.
Another item. That way people can vote stuff up too. So, but yeah.
So just wrap up the demo. The last thing we're going to do is 100 test queries without caching. This isn't very exciting. I mean, I made a really expensive query, so it's about 81 RUs, and it takes about 14 milliseconds. I go and repeat these test queries with caching. Any guess, Mark, what the RU charge is going to be?
0?
0. So the very first time you ran the query, we were charged RUs, right? But then repeated reads of the same query will utilize the cache. So we ran it 100 times. We paid for the query 1 time. And obviously the latency was much lower when the request hit the cache.
Yeah, definitely. This is great when you've got like big, fat, heavy, like fan out queries, and like say you just get stuck with your design, and you start scale out, and you realize, oh no, I picked a terrible partition key. I've got to run all of these fan out queries just to keep the lights on for my workload. Something like this would be a lifesaver, basically, because you could cache all those big, heavy, expensive, slow queries and serve them from there. So, yeah, this thing is great.
Absolutely, it can help in those scenarios, and it can also be actually super helpful if you have a hot partition key.
Yeah.
Because if you think about what a hot partition key is, it means you're most likely repeating the same operation or same type of operations again and again. So if you have a hot partition key and it's due to a lot of reads, that might actually be a good thing. It might mean that, maybe if it's a hot partition key because of a certain query that's repeated again and again or something like that, it might mean that workload's a great candidate for caching, and you could go and save quite a bit. We had some customers try out the feature in a private preview in the 6 months leading up to the public preview. And the biggest thing that impacts how much you're able to save is the degree to which queries repeat themselves. So we had some customers that basically their data doesn't change all that much, so they're okay with a pretty large cache TTL, and they have the same queries just running again and again, pounding Cosmos DB. These are customers that can save in excess of 90% on their workload, right? Because if you take your queries and they now are 0 RUs, even if the query was incredibly expensive before, it can make really large-scale workloads incredibly cost-effective on Cosmos DB.
Is there for the instance sizes you have? Did you have memory listed up there as well? Like how much memory do you get for each of those?
I'll pull this up again. It's a really good topic to bring up. So right now you have 3 different instance sizes that you can choose from. Between public preview and GA, I'd look for us to add a few more, but right now you can choose from D4s, D8s, and D16s. And for each of these, you have a certain amount of CPU and memory, right, for each instance. Now, in the vast majority of cases, this is going to be your bottleneck. It's going to be memory if you just need to cache more data. So in our docs, if you actually go to that doc that Mark you had just shared, it's either on that one or one of the other cache docs. We have a section on metrics. I check that out because it gives some good tips for understanding if the dedicated gateway size you provisioned is either too small or too big. But in most cases, I mean, your starting place for what size dedicated gateway you want is going to just be based on the amount of data you need to cache. So in most cases, customers won't need to cache that much. Like a few gigabytes should be more than enough. Yeah. So I mean, D4s would be the way to go. But if you had a really large scale workload, then you can increase the size accordingly.
And you could use query stats to get the payload size back, right? So you could actually use that to figure out, just to help your planning, I guess, with that, just to see. So yeah.
Cool. Yeah. So I mean, try it out and don't be shy about sharing feedback. The great thing is, I mean, it literally takes less than an hour to try it out. I mean, it would take you, I mean, quite literally 1 minute to change your app to work with the dedicated gateway and integrated cache. All you're doing is changing a connection string, and the rest of your app, whether you wrote it yesterday, whether you wrote it 3 years ago, will all work as is and leverage all the cost optimizations of caching.
Yeah, super cool. I know a lot of customers who are really excited about this, Tim. So again, here we are at Build, just shipping some just fantastic stuff. What a great team to work on. I'm so happy. So, well, thanks, Tim. That was great. Yeah. And so last up, we've got Deb with us. Hey, Deb.
Hey, everyone.
Yeah, the star of Build for us, and has been just patiently hanging out, watching all these great features. But why don't you share something else that we talked about this week, our last topic for this week's stream?
Yeah, last but certainly not least, we're really excited at Build to announce that we are increasing the free tier amounts for Cosmos DB. So who doesn't like free stuff? So with Cosmos DB, for the past year, we've had a free tier that's permanent that previously gave you 400 RUs and 5 GB, so a good amount to start with. And based on the feedback and just looking at the usage of free tier for the past year, we've decided to raise the value and the amount of RUs in storage to make it even easier for you to try out Cosmos DB and get started. So free tier now gives you the first 1,000 RUs and 25 GB for storage for free in the account. If you already have a free tier account where you're using it, you automatically get the new quantities applied. And if you haven't, you want to create a Cosmos DB account right now, you get 1 account per subscription that can be free tier. Just hit apply in the beginning and just make your account. In addition, once you have the account, we have a lot of cool getting started materials to basically make it easy for you to try out Cosmos DB without having to really write too much stuff on your own or do too much research in the beginning. So in your data explorer, we have this gallery here, which has some sample either Python or .NET samples to get you started. This one is pretty popular. It has basically some sample .NET code to just show you how to use the SDK, how to create a database container, how to import sample data using one of my favorite libraries, Bogus, which we use all the time for generating some sample data. Teaches you how to run a query using the .NET SDK. And then there's also some built-in visualizations as well. I'll actually show it. I have it running here.
I think Bogus is everybody's favorite good package on this team, isn't it? So
yeah,
we can work on a database product. Having a data generator, ET data generator is important.
Yeah, I've got a nice built-in sample here for that as well. So yeah, all these samples that we showed here, they all run under 1,000 RUs or less. So definitely check them out. We've got official samples from our team. We have ones that have been submitted by the community here as well. You can also submit more things here via our notebook samples. But we're really excited to see what you do with free tier and looking forward to your feedback.
Yeah, 1,000 RUs. I mean, you can, like Tim was saying earlier, 1,000 point reads a second. That's not, that's not chicken scratch there. That's some real stuff, right? You could actually, and I've seen on Twitter as well that this announcement also got quite a bit of feedback. Like people were like, oh, I'm going to migrate my little hobby app, and now I'm going to use free tier for that because easily enough with 1,000 RU and 25 gig of storage, you can run, non-trivial apps using something like that. And you get 1 per subscription. So if you got more than 1 subscription, you can get multiple free apps. So in fact, here's a URL if anybody wants to go and look at the docs on that. There's more details for that on there. And well, that's it for this week. What a great show! This was the best one yet, I think. So, except for all of you that have done other episodes with me. So, everyone, join me. Thanks for joining us this week, and thanks for tuning in to Build. Next week, I've got a special guest, Matthias from our SDK team is going to join, and he's going to show you all of the insides and the secrets and the tips and tricks for our .NET SDK. I've got a sneak peek of this, and boy, this is going to be a great show. If you've ever had questions or just wanted to get the most out of our .NET SDK in terms of the performance and the tips and tricks and that, you got to check out next week's episode. So I guess that's it for this week. Thank you all for joining. This is a long episode, but man, such cool stuff. And I gotta have some of you guys come back too, right? We got to do more of a deep dive on some of this stuff, definitely. So, okay, well, that's it for this week. Thank you everyone for joining, and we'll see you next week. Bye-bye.
Bye.
Bye.